Hello friends, in this session of signals and systems, let's try to understand some of the properties of systems. We'll also try to understand what is system and its various classifications, and we'll try to understand some properties out of those classifications. So a system is generally an entity that manipulates one or more signals to accomplish a function, thereby yielding a new signals. A system can also be a combination of several systems, and the main thing is it takes input as the signal and it also gives output as the signal. We can see over here input is x of t, which is fed to the system. System does some operation on the input and provides the output as y of t. Some basic classifications of the systems are based upon its properties, which are listed as causality, invertibility, time invariance, linearity, and stability. We'll try to understand in this session the property of causality and invertibility of the system. So, causality is defined as if the output of the system depends on its present input as well as the past input also, but it must not depend on the future input. So one thing is clear, that an output can depend on present as well as past also. So if we try to understand this, it's like in causality it is possible to have some memory also. So it also indicates to system with memory too. Alright, let's try to understand this concept using some of the examples. So a system which possesses the causality will be called as causal system, and the other systems will be called as non-causal system. So you can see over here there's one input represented as x of t, which varies from -1 to 2. So case 1 is when the output is reflected version of the x of t. So we see over here the system is represented from -2 to 1, and according to the definition of causality, it should depend on only present input and the past inputs. So when we say past inputs, so those are represented by the values after the zeros in positive directions, and future values are represented as the values in negative directions before the zero. So we can see over here some values are present, that is from -2 to 0, as future values. So this is not at all a causal operation, so it is non-causal system. The next example is a delayed version of the input that we have seen over there. So we can see over here that all the values of these case 2 outputs are the delayed version of the input, or these are the past values. So according to the definition of causality, these are the causal operations. Also, this is a causal system. When we see case number 3, it is basically a combination of two inputs. One is the present input and the other one is the delayed version of it, or in other terms it can be called as past input. So again it fits to the definition of the causality. So yes, this is also a causal system. Now here is the question. Based upon the previous examples on the similar line, can you identify whether the system defined by y of t is equal to x of t plus 2 is a causal system or non-causal system? You can take a pause, think over this question and try to find the answers. Alright, let's try to understand the previous question. As we can see that x of t is present input, whereas x of t plus 2 actually is the future input. And according to the definition of causality, a causal system does not depend on the future inputs. So this system is, we can see, is non-causal system. Okay, let's try to understand the next concept of invertibility. So we say a system is invertible if the input of the system can be recovered from the output itself. So if we try to understand over here, Input is x of t. It is fed to a system with a function h, and the output is y of t. If I feed this output y of t to the another system whose function is h inverse, then if the output is x of t, then we say that this system is invertible system. Or we can see that the system to be invertible, the two operations must be reciprocal of each other, or multiplication of these two operations must be identity value or 1. Now, the next reflection spot. Based upon the definition of the inverse system, can you identify whether this system can be a invertible system? You can take a pause, think about the question, try to find the answer. Alright, so we can see that according to this system, input is provided to the system, and this operation that is being done by the system is it delays the input by an amount t0. So we get the output y of t as x of t minus t0. So if we can make another system over here which will cancel this delay, or in other words, it will make a delay of plus t0 to the system, then it will cancel the previous delay minus t0, and hence we will get our input again as the final output. So yes, this system would be invertible system, and we can verify this that functions of both the system operators h and h inverse is identity. So yes, this system is invertible system. So friends, in this session we try to understand the basic definition of this system, its classification, what is causal system with some examples, what is invertible system with some examples. We'll try to understand the rest of the properties in next session. Thank you so much.